Welcome to another edition of Nye's Notes. Here we're operating with positive and negative exponents. Just as a reminder for some of our lingo, we do have the number that's kind of written down below is considered a base. Anything raised to a power is considered that exponent. So if we're talking about adding the exponents, we're talking about adding those numbers to that power, or anything that we refer to exponents. Remember, that's the number that's being raised up above. So let's dive in. For our notes today, just going to copy down 3 example problems and just some general reminders, no definitions, just some things kind of have in your notes to help you with your homework and to help make sure that you're understanding how to continue to operate. For this one, we're just going to have you listen and we're just going to remind yourself of some general rule shortcuts, things that we've seen in the past. I have m to the 6th times m to the 3rd. As a quick reminder, that's 6 m's being multiplied together, being multiplied by another 3 m's being multiplied together. We said then our shortcut for this product of powers was simply then to add the exponents above. So the shortcut when we're doing product of powers was to add our exponents. And this was when we had common bases. So here I have m as my base, 6 and 3 is my exponent. So again, my shortcut was to add my exponents because now I just made a chain of 9 m's, or m to the 9th power, 9 m's all being multiplied together. So our shortcut here, product of powers, was adding our exponents. This is our first sample and have you jot down. This is just an example problem now that we operate in the negative realm of exponents as well. So if I have m to the negative 4th and I'm multiplying that by m to the 3rd, what I'm really going to say is that I'm still going to use that exact same shortcut, and then I'm going to add those two exponents together. So now when I add negative 4 plus positive 3, remember I have 4 negatives, 3 positives, cancel, cancel, cancel. I'm left with 1 negative. So therefore my final answer will be m to the negative 1, or 1 over m to the 1st, or 1 over m. Any one of these is a totally acceptable way to write that answer. M to the 1st is just one single m, and remember we can convert negatives to positives by dropping that negative exponent down to a denominator. So shortcut stays the same, add your exponents. What I really want you to have written down is just this sample with our little shortcut. For a general reminder, and again, just listening here, we're having quotient of powers, and that's when we divide exponents with common bases. We said our shortcut for quotients of powers was to subtract our exponents. Because if we remember, we have 13 m's, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 over 7 m's, 1, 2, 3, 4, 5, 6, and 7. Cancel, 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 and cancel, because all of those are dividing an m by itself, which equal 1. So all those cancel out. What are we left with? We're left with m to the 6th in the numerator. So m to the 6th over 1, which again, we don't need to write. But m to the 6th power would be our answer. And again, our shortcut back to this original was just subtracting. 13 minus 7 does equal 6. M to the 6th power. So your shortcut is to subtract your exponents. We're going to see how that looks on the next slide with negatives. So with this one, I'm going to have you jot down this example. When we're having negatives in our exponent, maybe I have m to the negative 3rd over m to the negative 7th. I'm going to use the exact same shortcut. I'm going to subtract my exponents, but I just got to make sure that I'm being super careful with subtracting my negatives. So when I'm subtracting these negatives, I'm going to take negative 3 minus negative 7, negative 3 minus negative 7. When I'm thinking of the world of subtraction, I'm thinking about keep, change, change, because I want to make sure that I'm not just trusting my gut with some of these negatives, but I'm making sure I know exactly what's positive, what's negative, and what cancels out. So if I keep, change, change, I have negative 3 plus positive 7. After keeping the 3, changing the subtraction, changing the second number. And if I have negative 3 plus positive 7, 1, 2, 3 negatives, 1, 2, 3, 4, 5, 6, 7 positives, I get some things to cancel, 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 and cancel, cancel. What am I left with? 4 positives. So my answer is going to be m to the positive 4th, because I subtracted my exponents away and I got m to the 4th. So same shortcuts, just got a little more complex information. And I would keep my answer as m to the 4th. Our next one is just a listening one. This is, again, the power of the powers. We have k to the 3rd being raised to the 4th. Remember, this is saying take k to the 3rd to the 4th power. So k to the 3rd 4 times, all being multiplied together. and remembering here that each one of these k to the thirds has 3 k's. So now if I have k to the third, k to the fourth, I'm really looking to see how many total k's do I have. Well, I have 4 sets of 3 k's, so that's 12 k's in total. So my shortcut was to multiply my exponents when I have a power raised to another power, because I'm just making different groups of that original exponent. So my shortcut was to multiply when I have powers of powers. We'll see an example now with negatives. If we're looking to do negatives, this was the last one I'm going to have you jot down. Our example problem is going to be, let's go j to the negative fifth, and we're going to raise that to the third power. So if we're looking at this one, I have j to the negative fifth being written 3 times, all being multiplied together. If each one of those have 5 j's in a denominator or negative 5 j's, I have 3 groups of them. So how many j's do I really have? Well, I have the same shortcut. I'm just multiplying my exponents. So I'm really just taking negative 5 times 3. 5 times 3 is 15. Now I just got to decide if it's positive or negative. I have one number that's negative, one number that's positive. The negative will carry it over. So I'm going to end up with negative 15. So my final answer will be written as m to the negative 15th or 1 over m to the 15th. Either one of those are totally acceptable based off your conversions. Your shortcut remains multiply exponents. The biggest thing I'd like you to have jotted down is just this section here to see that idea about multiplying those shortcuts. And we'll leave our samples from there, again, using these notes just to help you with some different ideas. Other things to do, check those purple tutor buttons in your examples from your book. Hopefully these help, and good luck today.